and welcome to the launch broadcast for Rocket Lab's 20th Electron mission running out of tows. Electron is fueled and ready for liftoff from Rocket Lab's Pad A at Launch Complex 1 in Mahia on New Zealand's east coast. My name is Muriel Baker and I'm here at Rocket Lab's Mission Control Centre in Auckland, New Zealand, where I'll be taking you through the launch of this dedicated mission for Earth monitoring company BlackSky. It is close to 10 p.m. on Saturday, May 15th. This mission has a window of approximately 2 hours, and we're expecting to launch right at the top of that window at 10:08 p.m. New Zealand local time. Our launch operations team are not working any issues, and with greens across the board, we're well set for an on-time launch. Running out of tows is a significant mission for the team here at Rocket Lab as our next major recovery test. For only the second time ever, we will attempt to bring Electron's first stage back to Earth under a parachute and splash it down gently in the ocean as part of our efforts to make Electron the world's first reusable small launch vehicle. Our recovery team is currently stationed in the Pacific Ocean, waiting for Electron's splashdown so they can retrieve it and bring it back to our factory for inspection. However, weather conditions have deteriorated significantly in the splashdown zone, which means we have limited live communications with the recovery team. Visibility at sea is also greatly reduced, so it may take some time to provide confirmation of a successful splashdown, and we may not get this during the webcast. Nonetheless, conditions are optimal for launch, so we are proceeding with the count. Today's recovery attempt will follow a pretty similar process to our first recovery attempt 6 months ago on our return to sender mission in November. But here's what's new for this mission. We've strengthened Electron's thermal protection system with an upgraded heat shield to help protect the booster's Rutherford engines. We've also refined our retrieval logistics and introduced the Ocean Recovery and Capture Apparatus, otherwise known as ORCA, to our recovery vessel. This hydraulic cradle is essentially a recovery-optimized strongback to help safely bring Electron aboard. But maybe most excitingly for this mission is the fact that we'll be flying previously used components for the very first time. Electron returned in such good condition during the return to sender mission that we're reusing its propellant press system on this one. Now, with the recovery team out at sea patiently waiting for liftoff, let's take a look at what's involved in the recovery process. At approximately 2.5 minutes after liftoff, at around an altitude of 80 kilometers, Electron's first and second stages will separate. Electron's second stage will continue this mission's journey to orbit before the kick stage separates to deploy the satellites. Now, this is part of a standard mission profile, but next is where it gets interesting for recovery. During its descent, Electron will reach around 8 times the speed of sound, and the air around Electron will heat up to 2,400 degrees Celsius, generating an extremely hot plasma that creates a red-orange glow around the re-entering stage. To help Electron survive this brutal experience, a reaction control system on the first stage will orient the stage 180 degrees to place it on an ideal angle for atmospheric re-entry. From hypersonic speed, we decelerate the first stage to below Mach 2 before a drogue parachute is released to increase the vehicle's drag and help stabilize it. In the final kilometers of re-entry, a main parachute will be deployed to further slow the stage and enable a controlled splashdown. Our team on the recovery vessel will then rendezvous with the stage and bring it on board the ship with ORCA before transporting it back to our production complex for inspection. For tonight's recovery attempt, we'll have cameras on board Electron's first stage feeding us live footage, and we'll stick to those views as long as we can. But seeing as it's a night launch, our views will be limited by the lack of sunlight. We're also expecting to lose the camera view during a telemetry switch between our ground tracking stations. And due to poor weather in the splashdown area, we may not get real-time comms from the recovery team during the webcast. We'll listen out for the calls, of course, but if we don't get them live, we'll share updates on our social media channels to keep you posted on Electron's return to Earth. We're approaching T-minus 12 minutes in the count, and soon our operators will be run through the go, no-go poll by this mission's launch director, Sean DeMello. Let's listen in to Mission Control and check how we're tracking for launch.
All stations, LD and mission, proceeding with a go-no-go sequence at this time. Looking for your status to proceed for launch. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCon.
VCon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
Mission management.
MM is go.
Recovery.
Recovery is go.
LD sub.
LD sub go.
Executive.
Executive is go.
Go-no-go sequence complete. We are at 11 minutes, 12 seconds and counting. We'll go for terminal count start at T-minus 10 minutes. From this point on, the 3-word hold procedure is in effect.
There you have it. That's confirmation from Mission Control that all systems are go and will be proceeding with the remainder of the count. Liftoff remains scheduled for 10:08 p.m. New Zealand local time or 10:08 a.m. UTC. Now to this launch's primary mission objective. Running out of tows is our third mission for 2021 and the first of several dedicated launches this year for BlackSky, which provides geospatial intelligence and global monitoring services through their low Earth orbit constellation. Electron will be launching 2 of these satellites at a 50-degree inclination from Launch Complex 1 and deploying them to a 430-kilometre orbit. Once in space, these Gen 2 satellites will mean BlackSky can better deliver insights to decision makers, responding to disasters or tracking economic activity across the globe. Here's more from BlackSky. Running out of tows will be our 4th mission for BlackSky through launch services provider Spaceflight Inc. The first was Make It Rain in June 2019, followed with our second 2 months later on our Lookma No Hands mission. The third BlackSky launch on Electron was this year on our They Go Up So Fast rideshare mission in March. Tonight's mission is part of an overall deal to deploy 9 BlackSky satellites across 5 Electron missions this year that delivers them the rapid launch capability they need to expand their constellation quickly. For the team here at Rocket Lab, this mission also marks a couple of fantastic achievements, because tonight's launch will be the 20th time Electron leaves the pad, powered by our 200th Rutherford engine. It's incredible to think that we've built, tested and fired 200 of our unique 3D printed electric pump-fed engines. Rutherford is the world's first 3D printed orbital rocket engine, a unique design that went against the grain of traditional rocket propulsion systems when we first introduced the idea. Rutherford also made space travel electric by replacing the traditional gas generator cycle with electric pumps powered by lithium polymer batteries. This mission is one for the history books, so we sat down with some of the team who helped make it happen to talk through their experiences of our first 20 Electron launches.
What we have here is just a completely, defiant group of people who really want to execute and see things succeed.
It never gets old, whether it's the first flight to orbit or the 20th, whether it's our first customer or our 200th. We're learning something every single time.
I mean, I'd been here for 5 months. We didn't know if it was going to work.
It's mainly getting the customer's payload into space. It's game time.
Launch day is Space Super Bowl, right?
I don't even remember breathing, but it was worth it. It's a feeling you just can't describe. You just have to really be there.
I'm much more interested in the payload these days. So for the first few flights, it was all about the rocket. Whereas now, I get to know a little bit more about who we're launching.
Launch day is way harder than I thought it was going to be. I thought by the time you get to 20 launches or some number, it would just be like, making coffee. Everybody's just so invested in each launch that there's always so much energy around each launch.
Hearing that our first light satellites come alive and things like that it's a totally different feeling than just we've launched this rocket, and that's been awesome.
20 missions is a huge achievement, and it's been incredibly exciting, but I'm even more pumped for the next 20.
So I'm super stoked about recovery from the quality engineering perspective.
I like the fact that you get to launch the next. It means that you've done your job right.
I mean, fundamentally, we must have a really good design. The fact that we can launch this many rockets, Electron's a good product.
Rocket Lab's secret sauce is its engineers' dedication to rapid development.
We would not have been successful had it been a different group of people.
Oh, I think I'll be in front of the 20 flights.
Congratulations to every single Rocket Labber who got us to the pad today and helped us reach these milestones. A check-in on how we're tracking to liftoff. The team are working no issues with the launch vehicle, Electron's payload remains healthy, and the weather is looking clear for an on-time launch. We're approaching a critical juncture in the lead up to launch now, the switch to the countdown auto sequence. In T-2 minutes, the autonomous flight computers on Electron will take over the count. At around T-1 minute 30 seconds, we should hear the call that LOX loading is complete on Electron. And then shortly after that, we can expect confirmation that the launch vehicle's first and second stages are pressurized for launch, followed by the 10-second countdown to liftoff with engine ignition at T-3 seconds. Let's hand over now to Mission Control and listen in for those calls.
We are go for our sequence start at T-2 minutes.
HV blips nominal.
Confirm LDs go for launch.
Hold.
Got to hold. Recycling T-12 minutes. All stations stand by for recycle to T-12 minutes. GC confirm a launch inhibit mode.
Still in prime mode.
Confirmed they were inhibit at this time.
So you heard it there from Mission Control in Auckland. Right now, Electron has entered a hold while our operators work on establishing a new T0 time. We'll continue to broadcast while we wait for an update from the team. In the event of an extended hold, we'll provide an update via our social media channels. Thanks for watching. We'll be back with you soon.
Proceed with stage and report checks 63.
Copy, understood.
All stations will be setting the clock for T-minus 12 minutes, and we'll be holding up that time to resolve the hold called by GNC.
Vehicle is unexpected. Avionics terminal abort check.
All stations, LD and Mission, we're currently cycling back to T-minus 12 minutes. We have a hold called for winds aloft or upper right winds. We'll circle back once we've had an opportunity to review the data.
LD, GC on mission, launch vehicle secure.
If you're just joining us, we have entered a hold due to upper level winds and have recycled the clock to T-minus 12 minutes. We'll stay on the live view of Electron on the pad while the team assesses those wind levels, and we'll come back to you with a new T0 as soon as it's confirmed.
stage LD mission.
LD stage.
Configure OFVs with lock stopper.
Copy.
PLS proceed with lock stop after this time.
Roger, lock stop up in work.
A quick update from Mission Control here. As you can see, we're currently in a hold due to upper level winds. Stick with us as we establish a new T0 time. We'll let you know as soon as that happens. But today's window remains open until 12:05 a.m. New Zealand time or 12:05 UTC.
On all stations, LD on mission. We're currently holding the clock at T-minus 12 minutes while the GNC team work through further verification of upper air winds and running some worst case data. Expected time to pick up the count is no earlier than 11:11:39 UTC. That's for target T0. I'll report back in about 10 to 15 minutes when we hear back from GNC.
Hello again. As you can see at the bottom right of your screen, we are currently holding at T-minus 12 minutes. The team is assessing upper level winds to determine a new T0 for today's liftoff. All other systems remain go though for launch, so it's just a waiting game for those upper level winds. We'll update you as soon as we have a new T0. Another quick update from Rocket Lab Mission Control. We are still sitting tight on the pad, waiting for upper level winds to fall within bounds for launch. The clock is currently held at T-minus 12 minutes, so while we wait for that new T0, let's take a look back at our first recovery mission back in November last year.
Congratulations to the recovery team. That team has pulled off a miracle with re-entry of Electron in the first ever attempt. So in the return to sender mission, we set out to achieve a number of things, and all of those things increase in complexity and risk. The first thing was to reorientate the stage and get it in the right angle of attack. We've done that a couple of times before, so that was obviously very successful. And the next big thing was to start deploying the parachute systems. And we ticked off each one of those milestones one by one in a very successful manner, and then ultimately splashed down the stage at a really low velocity into the ocean in wonderful condition. So that was kind of like the giant. And in fact, there's even components on that stage that we intend to refly in an upcoming mission. So the thing I'm most excited about reusable Electron is two things. One, we can offer many more flight opportunities because we don't have to build so many rockets. And right now, we're pushing one Electron rocket off the line every 30 days. If we can reuse Electron, then we can create a lot more flight opportunities. Equally well, if we can reuse Electron and get them back in the condition that we're hoping now, it completely changes the economics of the small launch industry, which I think for our customers is really exciting. Electron is a reusable rocket. It's a great milestone, and I guess something a few years ago that I didn't even think was possible, so that makes it even more sweet.
Thank you for tuning in to today's launch broadcast. As you can see, the clock has resumed and we are currently at T-minus 17 minutes and counting. Electron might be the rocket on the pad today, but recently we announced plans to build its much larger sibling, Neutron. While we wait for a new T0, let's take a look back at that announcement.
When we say we're going to do something at Rocket Lab, we do it. Not just once, but over and over again. The Electron rocket defined a number of industry firsts. First carbon fibre rocket to orbit, in fact. Somebody told me once that was going to be impossible. And it's reusable. But then there's the engines. The Rutherford rocket engine, the very first 3D printed rocket engine ever to go into orbit. And in fact also the very first electric pump cycle rocket engine ever produced. And of course we didn't stop at rockets. We started building satellites too. Satellites to go to low Earth orbit, satellites to the Moon, to Mars and Venus and beyond. And there's a lot more to come. But first, I've got to take care of some business here. There's a lot of things at Rocket Lab that we said we were going to do that we've done. And a few things at Rocket Lab that we said we would never do, which we have also done. So I really think with this project, it's about time I finally ate the hat. The avoidance of all doubt, this hat is not tasty. But there's some things we said we would never do. But we're going to build a big rocket. It's called Neutron, and behind me is just the fairing. This is a purpose-built mega constellation building machine for all the mega constellations of today and of tomorrow. It's an 8-ton class launch vehicle, and of course, it's reusable. But one thing that's probably more exciting and most unusual for Rocket Lab is that this vehicle is capable of human spaceflight. Launching 2024.
We're all incredibly excited to bring Neutron to the pad, and we will have updates on its progress coming soon, we promise. We're approaching T-minus 12 minutes in the count, and soon our operators will conduct another go-no-go poll after the hold. Let's listen into mission control and check how we're tracking for our second attempt of the day.
All stations LD on mission chord, proceeding with the go-no-go poll for launch. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
Mission management.
Mission management's go.
Recovery.
Recovery is go.
LD sub.
LD sub go.
Executive.
Exec is go.
Go no go sequence complete. We're at T minus 11 minutes, 21 seconds and counting. We'll go for terminal count to T minus 10 minutes. From this point on, the 3-word hold procedure is in effect. GC, LD mission.
LD GC.
Proceed with sequence 50, pad terminal checks.
Copy proceeding with sequence 50, pad terminal check.
Avionics LD mission.
Go ahead.
Proceed with avionics terminal checks, sequence 51.
Proceeding with sequence 51.
LD GC on mission chord.
Go.
Stage 1 igniter pressures verified, hydraulic pressures verified, S1 pre-valve open, pad terminal checks complete.
Copy that. Stage LD mission.
LD stage.
Proceed with sequence 52, stage terminal checks.
Copy.
GC LD mission.
LD GC.
Proceed with pad ready for launch, sequence 53.
Copy proceeding with sequence 53.
Expander switch to high power for flight. Stage 1 and Stage 2 high voltage batteries ready for flight.
All engine blips are nominal, all engines are ready, the stage terminal checks are complete.
Copy that, stage. Avionics LD mission.
Go ahead.
Proceed with sequence 54, AFDS enable for flight.
Proceeding sequence 54. AFTS is green and enable flight.
Copy.
Hold on mechanisms armed, strong back retractor for flight. LDGC on mission.
Go.
BCS disabled, pad auto sequence is armed, pad ready for launch.
Copy. Recovery LD mission.
Go ahead.
Proceed. Confirm recovery as goes a green.
Affirmative.
And monitor them from the airborne.
Affirmative.
Avionics LD mission.
Go ahead.
Proceed with sequence 55. Enable recovery systems for flight.
Proceeding with sequence 55.
We are at T-minus 4 minutes and 42 seconds and counting. The strong back has been retracted for flight and those upper level winds are currently playing ball. From here on out, we'll listen into mission control as they proceed to T0.
All stations and missions, LD. From this point on, there should be no red flags in the critical LCCs.
HVB reports.
Copy that, avionics. VCON LD mission.
LD VCON.
Confirm flight computer as goes a green.
All as goes green.
Lock auto sequence and confirm.
Auto sequence locked.
All stations we go for auto sequence start at T-minus 2 minutes. At this time, LDs go for launch.
These are internal power. Confirm all stage power is disabled. Vehicle is on internal power.
Box load complete. System into recirculation. Anti-eyes ring disabled. High flow engine purge enabled.
Stage 1 and Stage 2 tanks are pressed.
Deluge activated.
T-minus 20 and counting. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2.
At T plus 30
Stage 1
seconds into
propulsion
the
is
mission,
nominal.
Electron is well on its way to space after its 20th liftoff from the pad at Rocket Lab Launch Complex 1. We had a great view from the tracking cameras of the
Entered
power
stage
of
one,
those
burn up
Rutherford
detect mode.
engines, with Electron clearing past 700, it's clearing well on its way to space right now. And very soon Electron will approach max Q, or maximum aerodynamic pressure. And this is the moment when the forces against the launch vehicle are at their peak during ascent. So let's listen in for the
Vehicle is
call that
supersonic.
Electron has cleared that
Good
gate.
ship run 1.
Approaching max Q.
HVP discharge nominal.
Max Q cleared.
Entering ship run 2.
There's the call out. Electron has successfully passed through max Q, with propulsion continuing nominally. In about a minute, we'll be coming up to 3 events that happen back to back during flight. First is
Guidance
main
is
engine
nominal.
cutoff, or MECO. This is when the 9 Rutherford engines on Electron's booster throttle
US
down
jet
before
station.
shutting off completely to slow the rocket down before the second event. That's when the first stage separates from the rest of Electron as it continues with the third event, ignition of the sole Rutherford engine that powers Electron and the satellites to orbit. With that stage separation, Electron's booster begins its journey back to Earth, and so will begin our second Electron recovery attempt. We'll hopefully have a live camera feed on that first stage to watch that descent take place. But before we get ahead of ourselves, let's wait
15
for the
seconds
call
to
out
go.
for those 3 events.
Stage 1 propulsion is nominal. And MECO confirmed.
Successful separation.
Stage ignition.
Recovery
And analyst recovery, proceed with sequence 59, stage 1 recovery operations.
Computing landing zone.
As you've seen, we've had a successful MECO and stage separation. No, there's been no ignition, sorry, but on your screen, we'll keep that view and see what we can come back to you with soon. Okay, so it looks like we've had a loss of telemetry. We'll come back to you with more information as soon as we have it. An update from Rocket Lab Mission Control. We are experiencing a telemetry issue with today's mission and therefore do not have live views of the vehicle to bring you at this time. So we're going to end today's webcast and bring you updates via our social media channels. Thank you for tuning in to today's mission. We'll see you back here soon.
Testing. There we go. Hey, so yeah, it looks like Rocket Lab just experienced an anomaly during their running out of tows launch. What happened was right after stage separation, it looks like they, well, you saw the engine go from red to glowing red to dark. It looks like they lost engine thrust, and they also lost telemetry about that time. And so it looks like this one is a they're going to have to take the L, as they say. Never a good day for a launch provider to lose a payload. Satellites are very expensive, and launches are precious. So condolences to Rocket Lab, and hopefully they figure out what went wrong so that they can fix it and move on. But I wanted to just come on and give you a quick update as far as what we know, which is not much. LP Quagmire, is that Bennu on the left? Yeah, that is Bennu. A picture of Bennu anyway. Okay, so if you have any questions, if you have any questions, go ahead and ask away in the chat, and I'll do my best to answer them, though I don't have much information about the anomaly. That is, we saw that second stage either, well, it was glowing, so it must have ignited, but maybe they lost thrust. I'd have to go back and see it, and I don't really want to. Actually, you know what I could do is pull it up on the screen and look at it with you. Okay. So, here. Okay? All right. So here they're approaching staging. This is at 2 minutes, 17 seconds into flight. And that's the first stage engine exhaust that we're seeing. By the way, the sparks are normal. It's just part of their system. Okay, so we have MECO, we have stage separation, we have ignition of the second stage, and then you see there's an interruption, and the second stage engine stops glowing, meaning it's well, it's no longer thrusting, it's no longer generating heat, and it's no longer heating the bell nozzle to the point of glowing. Let's look at that stage separation again. So we've got it's beautiful exhaust in any case. So we've got MECO, we've got separation, we've got ignition, and we have loss of ignition.
59, stage 1 recovery operations.
So it just looks like for whatever reason the second stage engine failed. You know, it was some sort of fuel pump issue or something. All right, let me go ahead and make this chat a little bigger so that I can see what y'all are saying. So Nodis Alcy said that it looks like that the first stage appeared to swing off to the side very quickly, as if the second stage got into a spin. That is possible. If we go back again and take another look. I mean, I did notice that, but so you know what I can do is I can compare it with a previous Electron launch. Give me a moment to queue up that video.
Stage 1 propulsion is nominal. And MECO confirmed.
Successful separation.
Stage 2.
Yeah. That looked awfully violent. Normally, here, while I'm switching. Okay, so let's check out this video from a prior Electron launch from March 22nd of this year. So we're approaching staging. We've got labels peeling off of the rocket, which has been known to happen.
Or what we call stages. Following that, the sole vacuum optimized Rutherford engine on that second stage will fire up to continue the journey to low Earth orbit. We're a few seconds away from those events, and those calls will come in quick succession. So we're going to cross back to mission control now.
So we've got MECO and staging, ignition, and look at that. It stays roughly straight. So that's odd. Why would it have? Why would it have? Let's look at this successful separation again.
And those calls will come in quick succession. So we're going to cross back to mission control now.
MECO, separation, second stage ignition,
Stage 2 ignition confirmed.
and no violent turning. All right. If we go back to this one. MECO.
Successful
Separation. Ignition, and flies off to the side. Strange. Second stage engine. I don't think it gimbals. So what could cause it? And it's out of the atmosphere at that point, right? So what's the altitude? Does it say? 90 kilometers. So it's basically out of the atmosphere. It's essentially, 100 kilometers is the Kármán line. So it's essentially out of all but the very thinnest of the upper parts of the atmosphere. And so it's not like it would be encountering any aerodynamic drag. So what could cause it to kick off to the side? Maybe there was a rupture of some sort above the camera where we couldn't see. But, all right, let me take another look at the chat here. Running out of tow. Yes, the tows were blown off today. Station 240, will they still attempt the first stage recovery, do I think? Probably, especially if it means a little bit of cost savings. I mean, it's still, worth their, well, especially because they may not reuse this first stage. I guess it depends on their investigation, but if there's any chance that the first stage might have played a part in the failure of the second stage, then recovering it and at least investigating it would be a good idea. So DDR forever, they don't land the first stage, they splash it down in the ocean, but yeah, still no helicopter catches at this point, but maybe someday. The Razor Wit. Can anyone explain to me why the rocket plume was full of sparks? It looked very different to say SpaceX. Yeah, for some reason the Rocket Lab engines produce a lot of sparks. They always do. I've heard. Now, bear in mind that these Rutherford engines, the core components of the Rutherford engines are 3D printed. It's possible that we're seeing, I'm sure these things are very minutely machined, very precisely machined. So I wouldn't expect there to be shreds of metal and rough edges and and little flanges that aren't polished off or whatever. Because normally when something is 3D printed, it's printed pretty rough, and in order to smooth it out or whatever, it needs additional processing after that. But I don't know what all their process is for producing these engines, but it's possible that there's some sort of ablative process going on whereby the the engine slowly eats itself, or there could be extra, because if we look at the actual chemistry of the engine, the Rutherford engine uses, what's its fuel? I don't even remember. Electron rocket info, first stage engine, Rutherford. Huh. Shame on me. I don't have the fuel listed here. Let me look it up real quick. I have the specific impulse or whatever. I don't have the... Alright. Rutherford engine, liquid... Okay, so it's LOX and RP1. Same as the Falcon 9, same as the Saturn V. So it uses LOX and RP1. So you wouldn't expect there to be any different products from the chemical reaction in this engine versus, let's say, a Falcon 9. Yeah, Atarusho sparks possibly from ablative cooling of the nozzles. That's definitely a possibility. And it should be noted that satellite insurance is a thing, and while oftentimes government launches are not insured, commercial launches certainly would be, because it's in the commercial interest of the customer to make sure they don't lose their investment, or make sure that their investment doesn't just go poof. So so yeah, BlackSky Global will be filing a space insurance claim. Definitely not the biggest, but yeah, no satellite is cheap. So Leanna says, so I see it as a second stage getting banged, but it seems to be a heavy tumbling spin. So the second stage, there's really nothing that could bang it, because when the first stage is jettisoned, it drops away down beneath the second stage. So it's not like it can come back up and bang it. Although, if we take another look at the footage, no, we saw Miko, so there was no more thrust on that first stage. And if there's no more thrust, then, for example, the first stage wouldn't be able to thrust itself back up into the second stage after separation. But let's just take another look to be sure. Okay, so we have Miko,
Successful separation.
and it's definitely dropping away. Yeah, and so it's normal for there to be some backwash. If we go back a few frames here, it's normal for there to be basically a reverberation of thrust from the second stage igniting, bouncing off of the first stage, and then possibly interacting with the bottom of the second stage again. But and we saw that in the other video of the successful stage separation. The second stage engine kicked in and it wobbled, like the rocket wobbled a little bit, but then it straightened back out. All right. Acidizer 69, is the Russian R-7 Soyuz rocket still the most reliable? I'm not sure what the metrics are. I mean, Soyuz is certainly a venerable workhorse of a rocket, but I don't have the metrics handy for failures, anomalies, partial failures, etc. No disalsi, no no disalsi. If I'm pronouncing that wrong, I'm sorry, but thank you for that donation, and thank you for your kind words. JD Brown, how did the telemetry go out during launch? Is that the first sign of a failed launch? Did the telemetry drop out during launch? I didn't even notice. Let's go back to the launch and see.
4, 3, 2.
Looking in the upper right, we see the speed and the altitude.
At T plus 30
Stage
seconds
one
into the
propulsion is
mission,
nominal.
Electron is well on its way to space after its 20th liftoff from the pad at Rocket Lab Launch Complex 1. We had a great
40 seconds and
power of those
650 kilometers per hour.
clearing past 700. Sorry, it's clearing well on its way to space right now.
Telemetry still reporting okay.
On maximum aerodynamic pressure.
Remember the
Forces against the launch vehicle.
stage separation was at about 2.5 minutes.
That Electron has cleared that
Good
gate.
ship, run 1.
Telemetry still looking good.
HVP discharge nominal.
MaxQ cleared.
Trim sheet run 2.
There's the call out.
1 minute 30, still looking good.
With propulsion continuing nominally. In about a minute, we'll be coming up to 3 events that happen back to back during flight.
Oh, okay. That's all right. Okay, so JD says he meant to say after the first stage jettison. So
To slow the rocket down before the second event.
we've just got a few more seconds until
Separates from the rest of Electron as it continues.
that happens.
Ignition of the sole Rutherford engine that powers Electron and the satellites to orbit. With that stage separation, Electron's booster begins its journey back to Earth, and so will begin our second Electron recovery attempt.
At least you know that the telemetry is live and not, you know,
But before we get ahead of ourselves,
canned or filtered.
call out for those 3 events.
Stage 1 propulsion is nominal.
Okay, so we're about to do MECO and staging. So there's MECO, telemetry is still looking good. Staging, boop, whoa, and the telemetry goes nuts. Speed is fluctuating a lot and generally going down.
As you've seen, we've had a successful MECO and stage separation. No, there's been
Still proceeding upwards though,
we'll keep
if you look at the altitude. Hey, Benna. I'm gonna jump up in my lap. We've still got telemetry. We have no video. So if we fast forward a little bit, oops. Oh. Okay, so they were still receiving telemetry. They didn't lose telemetry. They removed the telemetry from the view. I mean, from the broadcast. So I think they were still receiving telemetry, but they were like, okay, yeah, let's take that off of there because it's not good. So, all right, well, oh yeah, second stage is not going strong. Second stage at this point would be, well, I guess it depends on if it reached orbital velocity. Let's see what velocity it did reach. No, it was slowing down, and it was at much slower than it would have needed for orbital insertion or to achieve orbit. And so, yeah, it has splashed down at this point. Snow Kitten says it's ballistic if you ignore the fluctuations. RA30R says first stage was too close. I don't think so. It's normal for the second stage to ignite and then sort of blow off the first stage. They want to ignite it as soon as possible because as soon as it's safe to do so, because if they don't, like for every second that they do not ignite the second stage, they're losing momentum. They're losing their delta V that they spent so much fuel to get on the way up. You don't want to stop thrusting until you're out of that gravity well. All right. Candace Pear was taken asks, did you hear about the Candace rocket being built? I'm not familiar with that one. RA30R, at this point, can they reignite? It wouldn't matter if the rocket is in a uncontrolled descent or is in a spin. If they've lost control of the rocket, I mean, even if they could reignite the engine, they wouldn't be able to get it back on course. The rocket can't like make dramatic correction. You know, it's not like a sci-fi spaceship where you can just sort of, you know, turn and zoom, make dramatic corrections to your trajectory. Most of rocketry is you go straight and you nudge yourself in whatever direction you need to in order to circularize your orbit or in order to, you know, increase your speed to raise your orbit or whatever, but you make basically small changes to either speed or orientation. You know, but if the rocket is tumbling out of control, there's really nothing you can do to recover it. Now, I wonder, let's say SpaceX Starship, if a SpaceX Starship were to temporarily lose control, because it does have aerodynamic control surfaces, it has those canards and little mini wings, those fins. I wonder if it might be possible to recover a control of a Starship if it were in the atmosphere, like if it were low enough that it didn't enter at such an angle that you know, it couldn't handle the because they do plan on having heat, like a blade of heat tiles or some sort of heat tiles on the Starship, in which case you know, if it entered upside down, then it might not be prepared for that 3,500 degrees of re-entry plasma heat. Is New Zealand capable of launching a rocket? Well, New Zealand is capable of launching a rocket because that's what Rocket Lab is. They're really only an American company on paper. I mean, they're physically based in the U.S. and their manufacturing is in the U.S., but it was founded by a New Zealander. The launch site is in New Zealand. I think a lot of well, I'm not sure exactly where their employees reside, but I think their manufacturing facility is in the U.S. I think they based themselves, Peter Beck based the company in the U.S. Primarily so that they could have an easier time of getting the lucrative defense and national security contracts, launch contracts, like from the National Reconnaissance Office. There's a Twitter post. Let's see. An issue was experienced during today. Now, this was 8 minutes ago they posted this. An issue was experienced during today's launch, resulting in the loss of the mission. We are deeply sorry to our launch customers BlackSky and Spaceflight. The issue occurred shortly after Stage 2 ignition. More information will be provided as it becomes available. So that's pretty much boilerplate. That's what we were expecting. Obviously, you know, immediately after an anomaly, they're not gonna, you know, they still need to analyze the data and determine what went wrong before they release any of that information prematurely. Kishore Kumar, were all the stages pre-programmed, or was there some element of live interaction from the control center? Basically, these rocket launches are automated. I mean, the timing of everything and you know, the fuel flow rates and everything else is all very carefully calibrated beforehand, and the you know, the onboard computer reacts to different conditions automatically. Like, for example, the second stage shutdown is very possibly not because the engine failed, but rather because the computer shut it down because it detected that the rocket was in some sort of uncontrolled spin, or that it was way off trajectory, and you know, thereby not potentially risking some downrange location on the ground if, you know, if it were to continue thrusting and thrust itself right into a, you know, city or something. Oh, did Benny make an appearance? I wasn't even. Is he? Let's see. Is he on this tower now? He's not. So I won't put up Benny Cam. All right. Well, I guess that'll wrap it up. Obviously, this early on, all we can do is sort of armchair quarterback this. You know, the Rocket Lab has to look at the data and make some determinations. But, Mark Desire asking thoughts about the Chinese Mars lander. So, yeah. So I don't remember the name of it, but the lander portion, I think it started with a Z, the lander portion of the Tianwen-1 Chinese Mars mission, which has been orbiting Mars now for a few months, since February, when it arrived at Mars. So they sent down their lander, and there was much speculation yesterday as to whether or not they were landing and whether it was successful. But sort of per usual, the usual MO for China, they withheld the news until they were good and ready to release it. Now, there were people, like there's some guy, I don't remember his name, but some guy with a a radar telescope who had it pointed at Mars and was monitoring the transmissions coming from Mars, trying to make some determination about the success or failure of the Chinese landing. But yeah, all indications are that the Chinese rover did land successfully. I haven't looked at any articles or anything because it happened kind of late last night, and I was tired. But it looks like the Chinese lander did make it down to the surface. And of course, you know, as members of Western society, we would prefer it if China were more open and live about their, you know, their space endeavors. But you know, we'll get what we get. Snow Kittens says the rover is named Zhurong. Okay, Zhurong. Atarusho, will I stream Black Brant later after Starlink? So the Kinetex mission, it's an experiment that NASA was going to launch on a Black Brant suborbital sounding rocket. That it's been delayed a few times due to weather, and a couple days ago, while preparing for launch, the rocket came into contact with some piece of ground equipment that they wanted to do some checks to make sure the rocket was okay. But yeah, I think I will stream Black Brant. If the skies are clear enough. Now, I live in North Carolina, where, especially getting towards summertime, the skies get very cloudy, and you know, you wouldn't. I mean, you think North Carolina's hot, right? But it's also very stormy and cloudy in the summertime, especially. So, if my skies are sufficiently clear, I might be able to see that launch from here in Charlotte, where I live. I'll just have to look to the east, because the trajectory is going to take. It's going to launch from Wallops Island in Virginia, but the trajectory is going to take the rocket to the southeast-ish, and therefore by the time it's visible to me at about 30 to 45 seconds after launch, it would be, I think, roughly to my east. But they need clear skies in Virginia, or in Wallops. They also need clear skies in Bermuda, because it's flying in that direction. But it's going to be releasing some sort of a vapor trail or something like that should be visible, and for like a few hundred miles in each direction, which is pretty cool. So hopefully we'll get a chance to see that. If I do stream it, which I think I will also want to... Oh man, I have so many trees. I was hoping to go to higher ground, or to at least a better vantage point to set up a camera, because I've never seen a rocket launch. I've never seen a rocket in the air before with my own eyes. So I was hoping to maybe head to the top of a parking deck or something, because I have all these tall trees around my house, and I actually can't see a whole lot of the sky. I have no horizon here. My old house, which I recently moved from, actually had much clearer views because it was a much less forested neighborhood. I like the forest, it's great, but it prevents me from seeing much of the horizon. But Oliver Hancock, whoa, what kind of money are we talking to have the capability to even realistically have a possible attempt of intercepting comms from Mars? I have no idea. I mean, you just need a radar dish and the equipment to... a radar dish that's of reasonable size, and the equipment and software to decode the signals. I'm not a radar guy. There was a ham radio operator in here earlier. Maybe you could ask him what it would take. But Scott Murtaugh, did I see this week's House Appropriations Committee hearing that Space Force announced its HQ will be located at the old Redstone Arsenal in Huntsville? I was not aware of that. So Huntsville, Alabama has always been a big player in the space industry in the U.S. There's the Redstone Arsenal there, the U.S. Space and Rocket Center. Now, more recently, Blue Origin has their BE-4 engine manufacturing facilities there. Smarter Every Day is there. Destin, he lives in Huntsville and works in some capacity for some space-related organization. All right. So, Terrible T thanks me for staying live to discuss. That's no problem. I do like to come on live when I can. I just, I'm actually really starving right now. I'm distractedly hungry. So, my oatmeal is right here waiting for me, and it's getting cold, so I'm going to start gnawing on my arm here pretty soon. All right, well, thank you all for coming. I think that's going to wrap it up for today. Appreciate you all joining us for this unfortunate turn of events for Rocket Lab. They were not successful. Their launch looked good up until stage separation, and then the second stage appeared to tumble out of control, and there was also a loss of thrust, possibly as a result of the loss of attitude control. But yeah, Black Brant will get their insurance money, and you know, Rocket Lab will conduct an investigation, and they will definitely fly again. But until that time, until next time, maybe until later today during the Black Brant launch, if it goes up without another delay, keep it raw, and I will see you later.